Okay, we're moving on to our next case study with Ben Fino-Radin and Kate Lewis, so let me introduce you to them. Ben Fino-Radin is a museum professional specializing in the preservation of digital contemporary art and cultural heritage. At MoMA, Ben serves as digital repository manager in the Department of Conservation and also serves as an adjunct professor in NYU's moving image and archiving. I should be able to say that. Oh dear. Moving Image Archiving and Preservation Program. Fino-Radin holds an MS in Information Science and an MFA in Digital Art from the Pratt Institute. And Kate Lewis is a media conservator at MoMA, where she focuses on the conservation of audio, performance, software, video, and film-based works. She presently serves as program chair for the Electronic Media Group of the AIC and is on the editorial board for Studies in Conservation and is part of the Matters in Media Art project. Prior to joining MoMA from 2005, she was a time-based media conservator at Tate London. Lewis holds an MA in the conservation of works of art from the University of Northumbria in Newcastle upon Tyne and a BA in the history of art from the Courtauld Institute of Art, University of London. Please welcome Ben and Kate.
Good afternoon. So Long March Restart is the title of a software-based work in MoMA's collection by the artist Feng Mengbo. It was created in 2008 and the museum acquired it in 2009. And this March, it went on display at MoMA, and it's up on display for a year until April 2016. So in this case study, Ben and I are going to take you through the preparations we went through to prepare this work for exhibition and what we learned in the process. So I'm going to start by showing you a video of the work to give you a sense of what it's like to experience this particular piece. So as you can see, the game is for a single player who interacts with the work using an Xbox 360 wireless console. And the work is experienced in this sort of immersive, interactive environment, in this sort of corridor-like space. And the sound effects, as you heard there, a little bit tinny, they're reminiscent of sort of 1990s video games. The player's avatar is a red army soldier who progresses through 14 different landscapes or levels, which include rain, ice, fire, factories. And on his journey, he shoots Coca-Cola cans at various demons and ghosts. Sorry, slight delay. So this is the gallery without any visitors in it, and it gives you a good sense of the size of the space. And it also shows that there's 8 projectors which actually create this kind of immersive image, 4 on each side. And next to each projector is a speaker. At the entrance of the gallery at the far end, there's a small black plinth, and that's where the wireless remote lives when it's not being used. And there's actually a charging station on that plinth, so we can keep it charging. It's not on there very much because it is actually quite a popular game in the galleries. And this shows you what's running the game behind the scenes. So it's a PC, and there are a lot of cables. So we began our preparations for this work back in November last year, and we started like all conservators. We gathered all the physical objects in one place to see what we really had. So on the screen here, you can see there's a custom-built PC, which runs on 240 volts. So there's a transformer to go with it, because it came from China, where the artist is based. There's a wireless mouse and keyboard, a 360 Xbox console, and a DVD-R containing the game. On the back of the screen, on the back of the computer in the top right, let's see if I can get this right. Here, that's the back. I'm going to look at those 4 bits there. These are 2 Matrox video cards that are slotted into the PCI slots. and each of the card has two DMS59 connectors. DMS stands for Dual Monitor Solution, and basically each one of those provides two VGA outputs. That stands for Video Graphics Array. So from those 4 slots, you can actually get 8 outs, and that's how you get to your 8 projectors. These cables here are the splitters. So at one end is the DMS59, and then at the other end you've split out into the 2 VGA cables. What we didn't get with the work were the 8 projectors and the 8 speakers. The work was shown shortly after it had been acquired at MoMA PS1 in 2010. So we had lots of documentation relating to the acquisition and also this installation. And this was done by MoMA's previous media conservator, Glenn Morton, who led the collection team. And they also conducted an interview, a very detailed interview with the artist at the time, because he traveled over to install the work. So as the work was going to be on display for just over a year, it was our priority to find a way of exhibiting this work without solely relying on the artist-supplied computer. So in order to work out how we would do this, first we really needed to dissect the anatomy of the work and to understand how the software and the hardware really interacted with each other. So to make the game, Feng Mengbo worked with a friend who was a programmer, and they used this software tool called Multimedia Fusion 2. It's a user-friendly sort of drag-and-drop visual creation program for creating game content. And then from this, they output the game, Long March Restart, as a Windows 32-bit executable file. The benefit of using a tool like this is that it has a simple interface, and it's a very easy-to-use format. You can literally drag your stuff in. The disadvantage is that it's proprietary, and so this process does not involve creating source code. So with this work, all we have is the executable. So we have this 32-bit executable file. Now, an executable file is a file in a format that the computer can directly execute, for example, by a double click. Unlike source code, executable files are not human readable. So in the interview with the artist, he commented that everything that you need for the game is in this executable file, which is this here. Actually, there's 2 versions of the executable. That was the latest version, so yeah. But during our investigations, we found out actually that part of the audio is actually embedded in this FLC file here. There's a WAV file, and it's the audio that's very specific. There's a startup bit of the game, and that's where this audio file plays. So if you don't have that, you don't get the audio bit in here. So how do the software and the hardware interact? Well, the game, the executable file and this accompanying audio file, is running on Windows XP, which the artist loaded onto his custom-built PC. In fact, this game could run on any version of Windows, but this is the version that's loaded onto the computer. On the back of the PC, as we saw, are the 2 Matrox video cards. So the computer sees the game as one continuous image with a resolution of 2,560 pixels by 960 pixels. However, in the gallery, this one image is split into 8. So how is this achieved? So this is done by the Matrox driver software in combination with the Matrox cards. So a driver is a piece of software that allows your computer to communicate with hardware devices, so in this case, the Matrox video cards. So the driver takes the one large rectangular image and splits it into 8, creating this seamless projection in the gallery. So this diagram just shows how the image is actually divided into the gallery. So you have 2 rows. So row 1 to 4 is on the left side as you enter, and rows 5 to 8 are on the right side, with 8 being the first on your right as you're entering the space. So in addition to understanding how the game worked, we also wanted to just make sure that the computer actually worked when we switched it on. And because we didn't want to install this in this sort of large corridor environment, we worked together with 2 colleagues from IT at MoMA, Roger and John Paul, who you can see here with Ben. And what we did instead is we assembled 8 computer monitors, which we arranged on a long table, sort of mimicking the sort of layout of the projections in the gallery. So we plugged our VGA cables that in turn got plugged into the back of the PC. And to our great relief, it powered up and it worked exactly as the instructions said. So the next thing was to condition check the work to see that it was running according to how this game actually functioned. As you can see by the look on my face, condition checking is very serious business, but of course, it's very nice to go into work and say, right, today I'm going to play video games. So based on this research, Ben is now going to outline for you the options that we took for exhibiting it.
Great, thanks, Kate. So the case studies we've seen so far today have been very comprehensive, in-depth, lots of research as to significant properties, focusing on acquisitions. So the focus here, this is very similar to the piece that Joanna was talking about, where you are sort of coming, pulling the work out of storage, and this is all you have. However, in this case, that's all you have, and it's going on exhibition for a year and a half. So this study is really focusing on sort of easy, practical strategies for if all you have is an artist-provided computer, how you can put that on exhibition while still knowing that you have a backup, and a backup that is created according to best practices. So we'll be exploring 3 different options, 2 for exhibition, 1 for research. The idea of the replica, the backup copy, and virtualization. So when you open up an artist-provided computer, it may seem very confusing and lots of parts, and it looks very specific. But the fact is, these are all, of course, commercially available parts. So what we endeavor to do, of course, the hardware the artist provided to us is likely not very specific. The video cards are just accomplishing, they're a means to an end. And it's likely that the specific motherboard and CPU that was being used was also not specific. However, we understood that introducing new hardware could introduce variability in how the game performs. So as a way of creating a backup computer, but eliminating this possibility of variability, because we simply didn't have the time to confront these questions of variability, we decided to source every single one of these parts on the secondary market. In some cases, we were able to find them new, and assemble a custom PC with all of these specifications. So we were fortunate in the sense that the supplier of the video cards just happened to live around the corner from the museum. So here he is delivering a fresh batch, a whole stack of the Matrix video cards for our selection and inspection. And here on the left is the artist-provided computer. Here on the right is the newly assembled custom PC. As you can see, there are obvious physical variations in the hardware. The artist-provided computer was 240 volts, and this is the big power supply with the cooling fan here. Obviously, our power supply is located up here instead, and this is just a hard drive. However, more or less functionally the same, physically and computationally exactly the same. We then used a dedicated device for the replication of the hard drive. We'll be talking in a minute about the concept of disk imaging, and if you are attending the practical sessions tomorrow, you'll be learning all about that. However, disk images are not always required. They do make dedicated devices for simply replicating one hard drive to another. And this device, as you can see, also validates the replication. So it doesn't just copy the drive, but it also ensures that it is bit for bit an exact copy. So again, on the left, the artist-provided computer, and on the right, the quote-unquote replica. So this gave us a computer that we could simply plug in, power on, and it behaved exactly as the artist-provided computer. All that was required was a bit of hardware assembly and duplication of the hard drive. So this idea of the replica is something that was new, actually. This is the first time we've done this, and we found that it was a pretty easy process. The hardest part was just finding the parts, and it just happens that these parts were still available. Of course, stockpiling is not always an option, but in this case, it was certainly feasible. So we also experimented with the strategy of making what we have termed a backup copy, because we don't really have a better name for it. But this entails just taking a PC from a similar era with a similar operating system, and putting the artist's software on that computer, installing the dedicated video cards, and installing the drivers manually. And we actually found that this process was far more labor intensive because when you replicate an entire hard drive, that includes the operating system, all drivers, all settings, and you don't have to have a full, complete, in-depth understanding of every aspect of how that machine functions or how its operating system is set up, because it's just replicating that for you. So there were things that we had missed. The Matrix video cards were configured in the software in a way that we didn't even know they were configured. So when we tried creating this kind of manual, less exact backup, you might think it may be easier because you can just take any PC you have laying around. However, it proved far more challenging than sourcing the dedicated parts and replicating the hard drive. So it was during this process that we also discovered that the artist-provided computer was actually not just Windows XP, but it was a simplified Chinese distribution of Windows XP. So when dealing with international works, this can be a great challenge. When you're exploring, let's say, a replicated copy and you're trying to change settings, it can be quite challenging. Luckily, there were members of our IT team who are fluent. So we then, with the replica in hand and with the quote-unquote backup, decided to experiment a bit with how we might access and play the work with neither of these. So first, we created a disk image. A disk image is essentially a file that is a complete recording of the entire contents of a hard drive. It's a process of basically taking the hard drive, piping the data out of it, and just making a recording of that, in essence. The nice thing is that we can take that disk image and put it in a tool called VirtualBox. So Patricia and Annette will be talking quite a bit about virtualization, but this is just an initial glimpse to show you that the production of a disk image allows us to, as you can see here, I'm running Mac OS X, but within that, I'm running Windows XP in a virtual machine, and this is the artist's software functioning. So this has allowed us to do kind of more careful assessment of just the general gameplay, not the real subtle behaviors and timings and speed of the game, but just the basic, how many levels are there, what do they look like, and things like that. And it also allows us to capture, good screen quality video documentation of the entire image of the game. So Kate is now going to take it back and talk about what we did when we deployed the replica in the gallery.
So, although we made two computers, we decided to use the replica because it just ran perfectly. And that's what's been on display for the last 7 months, and so far without problem, so that's really good news. The other things that we had to think about while it was actually on exhibition is the wireless remote. So it can run out of power. And the wireless remote talks to the computer with a technology, it's 2.4 gigahertz radio frequency. So if the PC or the remote loses power, you lose the connection between the two things. So we didn't really want that happening while it was on display. So we have this, as I think I mentioned, we have this recharging station actually on the plinth as you enter. So when you're not playing it, it's recharging. But we also have a charged backup actually Xbox console actually inside the plinth should anything happen while it's on display. That can just be sort of whipped out. We work in a big museum, power cuts happen, so we also have if there's a power cut, we have a start-on procedure. So the AV or the IT team who might come and do the start-on in the morning, they know that they have to switch on the Xbox 360 first, and then go and switch on the computer to make sure that you have the connection between the two. So this image shows the challenge of setting up projectors when the PC is actually in a different room. But thank goodness for iPhones and Skype, because it's quite a challenge making sure, although everything was clearly labeled, there were issues with trying to get the right projector out of the right slot, because it has to be obviously in the right order as you're playing it, otherwise your man jumps around too much. But I just briefly wanted to talk about maintenance in general for these sort of works while they're on display. We are not doing any specific maintenance for this work. It is sitting in a gallery which has an uncontrolled environment. So we had a data logger running in there because we were a bit worried about the cold winters, the hot summers, and whether we'd get condensation. But fortunately, it's been running without trouble. We did watch it very closely for the first few weeks. But talking to colleagues about what they might do for maintenance of sort of just general things while they're on work, on display is somebody was saying that they might vacuum clean the computer to keep the dust out of the fan so it doesn't overheat. And then I also heard that at the Science Museum, sometimes they actually clear the cache of the computers that are on display. Our PC is not connected to a network in any way, it's contained. But something that Patricia mentioned at the tape, that if you do have a piece that's connected to the internet or somewhere remote, make sure that you shut down the auto update so you don't find suddenly some things up suddenly not talking to each other while it's on display. So just in summary, we made this replica, we made this backup, so we now have two things, so we don't have to solely rely on the artist-supplied computer. So I think this was a good solution in maybe the short to medium term. Also, the process of going through this, as Ben said, actually making the backup PC that we're referring to it as, was actually quite complicated, but that's where we really learned how this worked. The issues with the simplified Chinese, the issues with the audio file. So it was actually a very good process to go through. Clearly, the highest risk with this work going forwards is I think the Matrox video cards, which create the 8 screens of display. Because at some point that hardware is not going to be available. So although we've stockpiled for the medium term, it's not going to be viable in the long term. So another alternative will need to be found. The obsolescence of the video game is maybe actually lower risk because it runs on Windows, which is widely supported. So hopefully in the future, we're going to be able to use emulation strategies possibly to display it. And in fact, Roger from our IT team, he got it working on his Microsoft tablet. As you saw, Ben was playing it in a virtual machine. So what we're really working on now is the documentation of this work. And these things are really helping us. And it also, the nice thing about the virtual machine is it allows access for curators and stuff in the future, whereas before we had to literally set up these 8 monitors on the table. So of course now we also have our disk image in our digital repository, which is nice. The game is quite buggy, so it's interesting to hear that question earlier about bugs in artist works and all that kind of stuff, because we've been thinking about it with this. This is not a commercially made video game. It's not super slick. It does have these weird bugs, and for some reason, sometimes you're on one level and you get one sound, and if you go back to that level again, you don't get that sound. So there does seem to be some inconsistencies in the work, and Ben, who's much better than I am at playing the game, has also found when you get to the final level, you can't actually win it. I've never got to that stage yet. So what we're really trying to do now is document that. So I'm looking forward to Agata's talk that will be later about how do we really capture these works going forward. So when somebody does run it in an emulator, how do they know that those parts are actually part of the characteristics of the work? So I'd like to thank the AV team at MoMA who did a great job installing it, the IT team who worked with us, and of course our previous colleagues. And I'd just like to finish by saying, please come and play the game. Thank you. Any questions?
Sure. I'm Hank Kasbarsky. I'm at the University of Illinois. One of the issues that we're sort of hiding in the background is what the artist owes you. Does the artist owe you an executable or the source code? And if not the source code and you're not allowed the source code, can you deconstruct the executable to make fake source code? What do you think you're owed by the artist?
Well, in this particular case, obviously it's always nice to have the source code.
Especially if you have bugs.
In this particular case, there would be no source code. It would be the project files for, I'm blanking the name of the software. Multimedia Fusion 2. So those project files would in essence be the source code. Those are nice to have, but they're not a must for critical preservation. It's not as though if we had that, we would then be able to export it to some more contemporary format. I feel that the stewardship of a Windows 32-bit executable is much more viable than the idea of porting an artist-made video game that's in an incredibly obsolete proprietary WYSIWYG format. But yeah, source code and those such things are obviously always nice to have. And in terms of reverse engineering, I think Again, it's not a must, but obviously nice to be able to do legally.
Thank you.
My name is Eddie Colleton. I'm an NYU graduate student. And my question, I'm interested in this idea of a replica. Is it simply a better means to the same end as the backup or emulation? Or are you seeing this computer as having artifactual value? Or is there an added benefit to having an exact copy of the original outside of it just working better?
It's just a fast and easy way of creating a functional backup of the artist-provided computer. It has no artifactual value other than the fact that it's something made by the conservation department at MoMA.
Yeah, I mean, the term replica, we were discussing this when we were having all our calls before, like, what do we call this? And we had a long discussion, like, is it a replica? You know, this is quite a specific term in conservation. But I think it's actually quite a good strategy for these works is to make a replica when it comes in, especially if you're just getting one thing and it has to run in a very distinct way to kind of go through that process. Backup copy, again, that's a slightly randomly selected term. Maybe by the end of tomorrow we'll have discussed this further and have better terminology for these things.
Yeah. It was generally just recognizing that a disk image is great, and you should do a disk image and store that in your repository if you have one, or any kind of dedicated storage for preservation purposes. But what's more critical for exhibition is just having something you can toss into the gallery and know it's going to behave exactly like the artist-provided computer. Not requiring any extra setup.
Thank you.
Patricia Falcon from the Tate. Sorry, I was just interested in what you said about the project files, because that's what it's been at the back of my mind, because there's all this talk about source code, but actually there's loads of works where you don't have like proper source code, as in a list of statements that you can follow or understand. And do you have any thoughts on that? So.
It's interesting you say that, because I was wondering, can you think about it in the same way as video? So, you know an artist edits in Final Cut or something, and they bring all their rushes in, and they do their edits and their timelines, and then they'll output it as a video file. So when you acquire that ProRes video file or whatever, are we asking the artist for their project files from Final Cut? So I wonder in this particular example whether that's a comparison. And I think quite often we don't ask them. Sometimes they give you your project. They give you your project files because they feel like archival. I'm just going to give you all my stuff. But, it's like getting somebody's rushes. So, it's sort of like the sketches of the work. I think it's different to source code.
I think in some cases it is far more relevant, such as Joanna's case study at the Guggenheim, because that's a piece where, from a technical perspective, what it's doing was relatively simple, but if they didn't have those project files, what it was doing would have been black boxed. So reverse engineering it, or rather implementing it with different technology would have been very, very difficult if they only had the executables and not the project files that they could look at and say like, oh, okay, well, here's the URL to the server, and oh, this is how it's doing this. In the case of something like this, something complex as a video game, and something that is completely self-contained, I think that's the case where it becomes less relevant, if that makes any sense.
Yeah,
I wanted to ask Patricia a question. Well, I just wanted to ask, have you had any specific thoughts about that?
No, well, it's just because of John Gerard's Cell Farm. It's a 3D modeling software. So we could buy the software, but it's really expensive. And do we really then, are we going to recreate it? And actually the amount of code on it is fairly small. So there's a few calls, and it's mostly tools within the programming tool that you use. So it's sort of, can I really justify paying £24,000 for a software that we'll use once in 20 years' time, maybe? Yeah. It's sort of, it's tricky, because I'm sure in 20 years' time we'll love to look at the tool, but that's what's been on my mind.
It's one for the panel.
Thank you. And this is really unfair, but I'm going to make a comment. But, you know, for video files, we often do collect the project files, and we export the edit decision list in the XML file, which has instructions for how it was put together. So just a comment. Maybe we can talk about that later in the afternoon.